am I audible? Hello, Shikha. Hello. 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 Hello.
Yes, sir. Yogesh Jain here.
Good morning, sir.
Good morning.
Sir, we shall start in 10 minutes.
Okay.
सर मैं सच में बोलने वाली मेरा साथ दे बस सब लोग
साथ देने में कोई मतलब नहीं है मैडम, कुछ होने वाला नहीं होता
बोल
है।
के देखेंगे। वो मैंने एक बार बड़े सर को बोला, मुझे क्या बोलता, मुझे नहीं पता, मुझे करके जब तक मैं हूँ मैं टिल माय ब्रेथ इज आई वांट टू हैपन आफ्टर दैट व्हाट आल्सो मेरे को स्टेटमेंट मारा तो मैं क्या बोलूँ।
हाँ वही तो ना।
Good morning, one and all. We welcome you all to today's Sadgun Sang Meet, the 227th virtual webinar on Lifecycle Perspectives. Today's topic of Lifecycle Perspective will be taken by Mr. Yogesh Jain, sir. The speaker will be going through the following, that is the introduction of the Lifecycle Perspective, cradle to grave analysis, key principles and stages, LCP methodology, followed by question and answer sessions. The agenda for today's Sadgun Sang meet includes virtual inauguration by Dr. Sundar Kataria sir, evoking the blessings of deity, chanting of Gayatri Mantra, introduction to the speaker, presentation by Mr. Yogesh Jain, question answer sessions, and the closing session. Brief introduction of Sadgun Sang. Sadgun Sang, conceived and led by Dr. Sundar Kataria, driven with a mission to elevate the quality, safety, and environmental awareness levels of industry. Sadgun Sang is a series of educative, informative events aiming to illuminate professionals on possible solutions on current issues of industry and economy. Dr. Sundar Kataria is the chairman and managing director of International Certification Services. His academic qualifications are, he is a mechanical engineer from AMIE and also an honorary doctorate from business management. His experience is vast, including and not limited to nuclear and RAPP. He started his career in building India's first nuclear power plant at Rawat Bahata, Kota, Rajasthan. Also, he has led and contributed in developing India's first oil and gas field at Bombay High since his inception, that is in oil and gas EIL. He was the head of industry and offshore development with DNV for 2 decades, that is DNV, and till today, he is the founder of first Indian confirmatory assessment and inspection body known as International Certification Services Private Limited, also ICS, which is the provider of total quality solutions under single umbrella with a wide spectrum of services. His achievements are not limited but also include Lifetime Achievements Award from the NACE CONCON and has received several national and international awards. We welcome Dr. Sundar Kataria sir for the inauguration.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय सम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः
I request everyone to please join us for the recitation of Gayatri Mantra. The brief introduction of today's speaker is Mr. Yogesh Jain is the Director and Chief Consultant at Niche Quality Solutions Private Limited, India. His academic qualifications are he is BE Mechanical and MS in Consultancy Management with MTech in Future Studies and Planning. His areas of specialization includes mechanical and with a vast experience as a certified lead auditor for ISO 9001, ISO 14001, ISO 45001, FSSC 22000, BRC, HACCP, ISO 27001 Information Security. He is also a certified internal auditor for IATF 16949, AS 9100, ISO TSS 21163 and ISO 5001, ISO 37001. He is a trainer for Z, Sigma, Six Sigma Green Belt, Black Belt and Core Tools. We welcome Mr. Yogesh Jain for today's session. Over to you, sir. Hello, Yogesh sir.
Yes, madam, I'm connecting.
Hello, Yogesh sir.
In a minute,
Can you
madam.
hear
In a
me?
minute. Just a minute.
This company, I want to ask. Yes. Why are you taking seriously every Saturday? ये question विचार. ये विचार आते. पूरा देखेंगे ना. है ना अंदर.
Yeah, my screen is visible.
Yes, sir. ये question विचार. उसको डिप्टी मैडम में.
Hello.
Listen. Listen डालिए.
My screen is visible.
होगा ना. तो mic open करना.
Hello.
Yes, sir, we are able to see your screen.
Okay. So we continue. So today's topic, as Madam conveyed, we are talking on life cycle perspective. So when we look at clause number 6.1.3 of ISO 14001, the indication is that we should analyze aspects and impacts, and these should be done with a life cycle perspective in mind. So we need to understand the comprehensive impacts on a product or service through its entire lifespan. That is how the lifecycle perspective is going to be understood. It examines the environmental, economic, and social implications from raw material extraction through manufacturing, distribution, and the final disposal or recycling at the end of product's useful life. The holistic approach helps organization make informed decisions, minimize unintended consequences, and work towards a more sustainable future. So what is raw material? If we see the diagram on the right side, we start from raw material, go to manufacturing, then transportation, then installation and commissioning, then use the product, then it goes for maintenance during its lifetime. Once the lifetime is over, we need to either dispose it. If you can reuse it, then it is again brought back to service. If it can be repurposed, then again some kind of extension of life is there. If nothing is possible, finally it goes to landfill. So if we are able to understand what kind of energy is required at each stage, what kind of social requirements are there in terms of labor, in terms of electricity, in terms of other environmental aspects like emissions to air, water, land, then we are going to really understand in what way the processes should be designed so that we can economize on environmental front from life cycle perspective. Okay, I'll review. My hand is okay. Hello, is it okay now?
Yes, sir. Yes, sir.
Okay. So essentially, it is a cradle to grave analysis. As we pointed out, we need to trace inputs and outputs of our products and service from raw material extraction through manufacturing, distribution, use, maintenance, and final disposal or recycling. So as the diagram suggests, we need to understand how the product or raw material is extracted. If we go for an example of mining iron ore, and iron ore contains something like 62 to 64% of iron. You extract the iron ore using some kind of explosive, then those broken rocks or broken stones or broken ore is brought to the crusher plant with the help of dumpers and dozers. These dumpers consume diesel, then they have a life, the tires need to change, they have a replacement. Then this crusher crushes the iron ore into small size, which can be brought to steel plant. If it needs beneficiation, there is a process of beneficiation in between, wherein if there is a clay in the iron ore, that clay is cleaned off so that we get a better recovery at blast furnace. When the iron ore is brought to steel plant, at blast furnace in iron zone, we get liquid metal. And for getting the liquid metal, we need lot of coal besides iron ore and many other chemicals. So first stage is obtaining liquid metal from iron ore, which contains 62 to 64% of iron. In this case, we need to understand that around 36 to 34% of extraneous matter is given back in the liquid melting process of getting iron liquid metal from iron ore. Apart from that, we have lot of gases that come out as flue gases. We get blast furnace gas, which can be used for heating application in various other steel processes. So that is a byproduct. If that byproduct is not used, again that fuel or that heat is wasted. So this another area we need to look at. When this liquid metal goes to steel melting shop, there in the steel melting shop, we reduce this liquid metal into by treatment through vacuum degassing VD or through ladle refining process, we get billets of desired chemistry of high carbon, low carbon, whatever chemistry you want. So there at steel melting shop, you have lot of cranes working, you have ladles, you have oxygen lancing, you have several other gases, argon, etc. And we need to understand what kind of carbon footprinting is there for all these gases and electricity. If you talk in terms of footprinting, If you talk in terms of electricity, what kind of electricity is used, and then we get billet. This billet in the same steel plant may be rolled into HR coil or to various other flats, rolled products. Sometimes it may be rolled to a coil. These products become input to sheet metal industry or wire rod applications. So this is the primary output from a steel plant. Now for steel plant to run, we have captive power plant where a lot of coal is used, because a steel plant has to depend on not only power supply from state electricity board, but has to have its own power plant. So the component of power that it gets from its captive power plant has to be also factored into life cycle perspective of that particular steel plant. Once you consider what kind of per ton cost of electricity plus coal plus various other chemicals that go into making the steel, plus transportation of iron ore from the mines to the steel plant, then various internal processes, local transportation, staff movement, etc. When we consider, we get HR and CR coil. This HR and CR coil are converted to sheet or to coil of wire rod. Then these are converted to products like automotive components or sheeting for roof, which is used in rural infrastructure areas or construction industry. And then we need to understand how these components go into manufacturing of an automotive or heavy engineering industry related products like dumper or backhoe loader or those kind of products. And then we need to understand how child parts are being manufactured, what kind of plating and powder coating requirements are there onto them, what kind of welding requirements are there, what kind of electricity is spent on them. All those downstream processes on these into various industries need to be understood, and we need to check if we can economize on process, if we can reduce the process cycle, if we can cut down some steps. Somewhere we can be improving the life cycle and improve on our environmental footprint. We go a little deeper, similar kind of story will be there, and we will go and analyze this thing as we go further. So as I told you, input is iron ore from mines. We have taken an example of tractor loader backhoe. This tractor loader backhoe is manufactured by Caterpillar, also by your KS New Holland Construction Company at Pithampur, Indore, also by JCB also. So this is used with a bucket at the back and jaw in the front. And if you have seen that, this is used for land development and mining in a big way, small agricultural activity also. So in the raw material extraction, as I told you, we have mining, iron ore, coal, etc. Goes to blast furnace, gives liquid metal. This liquid metal goes to steel melting shop to give billet, which goes to rolling mill to give HR coil. Now, this HR coil comes to manufacturing. Before HR coil, it goes to sheet metal. So you get sheet of something like few meters by few meters, 4 by 2 meter or 5 by 3 meters or something like that, which goes into laser cutting, plasma cutting. This laser cutting or plasma cutting will entail again a lot of oxygen and electricity. Then the cut parts or laser cut parts would go for fabrication. Their MIG wire will be used. Again, carbon dioxide as a jacket will be used. This carbon dioxide goes directly into the atmosphere. Again, it is an environmental cost. Then there is some kind of electricity also involved. Then you go for painting and powder coating. Then when the product is ready, you pack it, and in the packaging, you require paper and plastic. Once the product is ready, you go for distribution using trailers or ships. There you use diesel. When you use the product for land excavation, there again you use diesel. So the diesel is used till lifetime. For example, if a loader backhoe is traveling or working for something like 5,000 hours in a year, and we say that something like 5 liters are used every hour, then something like 25,000 liters are used every year, and in 10 years time it will be 2,50,000. 20 years time it will be 5 lakh liters of diesel. Such much of exhaust will also go into atmosphere. For every 500 liters or 1,000 liters of diesel, we can assume 20% or 10% of lubricating oil required for engine. So that also needs to be considered. Then if there is a maintenance, as I told you, routine maintenance will involve oil, coolant, filters, tires, and batteries. Besides that, if there is any corrosion, erosion, some kind of painting, some spares, and such kind of requirements are also there. So if anybody tracks from start to finish for a product, what kind of processes are involved, what kind of environmental load is there, what kind of energies are required, what kind of associated products are used, consumables are used, and in making those consumables, what kind of electricity and environmental issues are concerned, then we can map the environmental life cycle in a much better way. Finally, when the product is at the end of its life, it needs to be disposed. Either it is scrapped and re-melted to bring back into service, some other parts of similar type, where some rubber, plastic, and such materials are used which cannot be reused, they go for landfill. Such products which are not used for any other reprocessing are going to increase the load of landfill site, and that also needs to be considered in how many years this plant has generated, what kind of landfill related unusable waste. Thus, we calculate environmental footprint, and the resource consumption associated with each phase can be worked out. So I've taken an example, as I told you, of a tractor loader backhoe. Again, where we have gone a little deeper, mining iron ore, using coal, using explosive, diesel, that is heavy engineering product, material movement machines, hydra and dozer and dumpers, then transport it from mine site to the crusher and to the steel plant. From blast furnace, you use electricity, oxygen, additives to get liquid metal, and steel melting shop, we get liquid metal. From blast furnace, we use oxygen, electricity, ferroalloys, scrap to give billets, which are rolled using electricity, water, lubricating oil to give HR coil. So this is how the detailing of the left side is done in a better way. We need to see in the painting and powder coating, there is sludge generation. So that sludge has to be also worked out, how much sludge is generated for per ton of steel working. Now, there is an angle of child part from suppliers at level 4 or serial number 4. Again, in child part, we have laser cutting, painting, powder coating, and if these child parts come from our vendor supplier, and if their processes are not in synchronization with environmental requirements, and if their environmental footprint is higher, we need to factor that into our life cycle analysis. This is going to help us understand how, as a company, what we are responsible for. We are not only responsible for assembling, we are not only responsible for our own manufacturing, but we are also responsible for any child part that we are getting from our vendor. If we can go to the secondary level, that will be very good. If we go to tertiary level, so we go behind the child part and go to lubricant supplier or paint supplier or powder supplier and understand their processes and what kind of environmental footprint they have. With this understanding, we will be improving our life cycle perspective in a much better way. So there are 2-3 angles. We look at input side, we look at processing side, and then we look at waste disposal. So when we look at waste disposal from company, we have waste segregated and disposed as per Legatrix is the software which a lot of companies use these days for managing their legal compliances. So for all kind of hazardous waste, such kind of waste need to be accounted for, and they are kept in record. Similarly, when the maintenance and child part supplier end is there, you have routine maintenance with oil, coolant, filter, tire, batteries that has to be taken care of. Similarly, at company service station, you have oil, coolant, filter, tire, batteries resulting into scrap. So at company, you have a processing. At dealer level also, you need to understand what kind of maintenance services are provided. Most of the times, if the customer is not bringing back the product to the dealer for servicing, what kind of environmental waste the customer is generating during its use, which is not accounted or which is going in the environment without taking or without being accounted properly, can be judged from the genuine spare parts or spare parts of aftermarket which are sold, and an accounting can be done from that perspective also. Finally, as automotive has brought in a recycling or scrap policy that after 15 years, if you go back to the government and say that I need to scrap the vehicle, give me a scrap certificate, go to the scrap dealer, and he will be giving you some scrap certificate which will be usable to buy a new vehicle at some discount. Similarly, a scrap policy is also being mooted or under active consideration for earth moving vehicle manufacturers also. Such activity is being done for various type of manufacturers where disposition can be done in a much better organized way. If such scrap is brought back to factory segregated way, then 70 to 80% of metal can be used in a scrap form by melting it back to the induction furnace back to use. Some material like glass may not be used, rubber beading may not be used, filter may not be used, but 70% is definitely possible to reuse. So if we do that, we will have a better idea. So as I told you, we can have inputs, coil from steel mill, consumable from supplier, life cycle assessment at child part supplier, and child part process activity from supplier. This will give us an idea of what are the inputs, processing at company, at development, if we are going for new model development, what kind of consumptions we are doing in terms of electricity, in terms of coolant, in terms of fabrication activity that we are doing, compressed air which we are using, and all those kind of things in the proto shop. During manufacturing, this will be much bigger in scale than development, say 1,000 times bigger, and we will have calculation of what kind of electricity and fumes and paint and powder and related sludge that we are generating. So on the consumption side, we have powder, paint, electricity. On the output side, we will have waste, that is exhaust, sludge, and scrap. Then we will dispose this waste from the company in hazardous waste site or recyclers for plastic and metal. During maintenance at company service station, we will have routine maintenance, that is oil, coolant, filter, tire, batteries. And at final disposal or recycling, company tie up with scrap company for its end of life products. This tie-up is now being made compulsory by Government of India for various companies slowly, and this is being made compulsory slowly, sector by sector. Thus, environmental footprint and resource consumption associated with each phase of company can also be worked out. Services after dispatch. So when the company is no more, into picture and the product has gone into customer hand, you need to provide instruction and communication to user for use of product. If they use genuine spares or recommended spare, and if the sale is in regulation or regulatory market, you would know what kind of spares are sold for each model tentatively, and you would understand what kind of scrap is generated during use. Then disposition of used spare as per user manual. If the customers are made aware, they are going to do it. If they are given an incentive to brought back the used spare, probably we will get something like 60 to 70% of used spare back to our recycling facility. Equipment or servicing from authorized service station. The tendency is that this costs more than our roadside mechanics. But if there is an incentive that if they are going to get the servicing done at authorized service center, their vehicle life will be better. They will have genuine spare parts and the warranty will continue to be with their product. In that case, we can have a campaign and make our environmental footprinting in a better way. So we have to promote maintenance at company service station. In the routine maintenance, oil, coolant, filter, tire, batteries will also get generated. And if there is a breakdown related activity or accident related maintenance or refurbishment, then lot of scrap will also be generated and new parts will also be put on to the old vehicle or old equipment. Finally, we will have to dispose with scrap companies which are going to break down the vehicle or break down the equipment into various small parts and segregate various products, glass into glass product, rubber into rubber products, and dispose with economic usage of each of them. Metal is one thing which can be reutilized by sending to remelting shop in induction furnaces. If you have copper used into fuel lines, that copper can be remelted and reused. If you have aluminium somewhere in the vehicle or equipment, that can be reused. So different metals can also be used and some kind of economic can be worked out. In the assessment of whole life cycle, then we need to understand what kind of opportunities of improvement exist. We need to understand how we can improve efficiency. So efficiency of lesser carbon dioxide usage, lesser battery usage, lesser electricity usage, lesser compressed air usage. And I've seen cases where people have been smart enough to reduce their oxygen consumption by 70% or 80% in fabrication plant. I have also seen those people who have reduced the argon to around 70%, 80%. MIG wire, the end, or sometimes if you do not do a regulated process, you end up using a lot of MIG wire as against the stipulated requirement. So again, it costs you and it also adds up to the environmental damage. You need to work on each of the input of improving efficiency and reduce waste. This is going to lead to development of more sustainable products, services, and system with a focus on circularity and reduced resource consumption. We have to collaborate across multiple stakeholders. So producers, waste management organizations, suppliers of spares and other materials, and consumers. If we have right kind of association with each of them and understand their processes, some people are at a better technological level, some people are better at environmental management level, some people are better at saving level. So if the skills are going to combine, we can get best of all the inputs and improve on energy efficiency and product process cycle. It is going to improve on your quality, it is going to improve your on cost, and it is going to improve on environmental also. So this cross-functional approach helps to align incentive, share knowledge, develop holistic solution that benefit all parties involved. There's a diagram on top right corner. Have a look at it. We have shown you scope 1 emission, scope 2 emission, scope 3 emission, which is being talked of in ISO 14064 in a big way for greenhouse gas emission. So whenever you are burning something to generate carbon dioxide in fuel form, then it is a scope 1 emission. If you are buying something which has carbon content into it like electricity, then it is a scope 2. If you are transporting or if you are getting your employees coming from their home to office or factory, now you don't have any control on their commuting practices. In that case, it will be considered as scope 3. So this life cycle perspective is going to be aligned or gel with your ISO 14064 related scope 1, scope 2, and scope 3 emission related calculation also. What are the key principles? It's a cradle to grave approach. So from start to finish. Like in food, we say farm to fork. Similarly, life cycle perspective on ISO 14001 is cradle to grave approach. So from raw material extraction to final scrap and if possible, reusage. Interdependence and interconnectedness changes or impacts in one stage can have ripple effects on other stages. Therefore, relationship must be carefully considered. As I told you, in the blast furnace operation of steel plant, you get a lot of blast furnace gas, which goes into your captive power plant also, and that goes also into direct reduced iron or sponge iron plant. If this blast furnace gas is not there, you will end up in using more electricity in sponge iron, and you need to probably generate more or consume more coal in your power plant. So better transportation of blast furnace gas from your blast furnace to these plant is going to help you understand and save on coal and electricity costs at sponge iron plant. Environmental, social, and economic impacts of product or service, including resource consumption, greenhouse gas emission, worker safety, community well-being, and economic implication. These need to be understood. When we talk of greenhouse gas, we have told you scope 1, scope 2, scope 3 emission. Worker safety, we have to take care of worker safety at mine, at steel plant, at iron zone, coming to consumer industry like loader backhoe plant, safety at that level. When we talk of child part plant, let us say fabrication shops or rubber product shop or glass shop, we have to take care of safety in those areas. When it goes to as a product sold to consumer, then we have to understand what kind of social issues are there in operating the product, and if there are accidents because of our product, and there are social costs involved over there. So we have to take a 360-degree approach and understand what kind of social issues related to worker safety and passenger safety or other safety that are concerned over there. Community well-being, since we are working in we are not working in an isolated way. Nearby industries, nearby residential colonies are also going to be affected because of emissions and because of wastewater generation and because of scrap that we generate. Therefore, we need to understand what kind of community affectedness is there because of our operations. It applies to steel plant, it applies to your loader backhoe plant and child part plant also. And then economic implication. If you study the life cycle perspective, economize on various stages and improve on your efficiency, energy, and life cycle related cost on inputs, processes, and output, definitely you are going to save on lot of money involved, and therefore economics will be better for your product and it will give you a competitive advantage. There is a possibility of continuous improvement, therefore. You have dynamic and iterative process. As I told you, initially start with the primary process, then go for secondary processes of your child part plant manufacturers. Then you can go for tertiary analysis of suppliers to child parts and your company. In that case, what will happen? That you will understand the life cycle involved at glass manufacturer, at rubber manufacturer, at paint manufacturer, and if those things are also considered, their process is understood, their activities made economized, social implications understood, and environmental matters of GHG emission and resource consumption worked out, probably we will have a better control of overall life cycle of all the products involved in our final product. Then when we go to consumer, we need to understand similarly how are the mechanics and how we can improve their life and how we can work on the driver side of health and well-being and how that can be improved upon. If you have gone through a little social news, Tata came up with some kind of spectacle for glasses for their drivers, vehicle drivers. That is all social activity that they did, not for only social cause. They wanted that some kind of brand image will build up if they are taking care of Tata driving vehicle drivers and their eyesight is taken care of, there will be lesser accident. If there will be lesser accident, Tata will have a better brand image, and the responsibility that Tata has taken for driver health will be repaid by driver recommending Tata products in a better way. Collaboration and stakeholder engagement. We can have collaboration between supplier, customer, industry peers. So whichever industry areas we are operating in, regulatory bodies, to gather data, share insight, collectively work towards sustainable solution. There are a lot of NGOs that are actually well-meaning and they are working in this field, and they can also help us understand what kind of equivalent possibilities are there, what kind of alternate materials are there, how the things have to be seen, and they might help us in understanding implications of our product and processes on social well-being of society. So when we were talking of interdependence, interconnectedness, we can think of make or buy or vendor related discussion, whether near or far. You can get a better quality from far away supplier. But if you develop a vendor nearby, you save on economic cost as well as transportation cost, your planning cost, and overall environmental cost also. Change of make, design change, packing, change from wooden to metal, reusable trolley, recyclable material. Lot of activity and thinking has gone into transportation of automotive components, but this has not gone into various other industries. Cement is still being transported into 50 kg bag. If it can be brought to 1000 kg bag, jumbo bag, which India has been exporting in a big way to foreign markets, but it has not been using itself into Indian market itself. If those can be done and those bags are properly emptied out and brought back to refilling, brought back for refilling after folding them, at least 6 times a bag can be reused. That way, your 50 kg bag is never reused. They use a cutter to open up the cement bag and the bag becomes totally waste. Earlier it was gunny bag. Gunny bag used to be still used for moistening the road or construction plaster by putting it, the gunny bag, unfolding it and putting it over there with water onto it. That possibility is not there with HDP or PP bag. So we need to evolve our practices when we have gone for a better bag, because jute plantation is not such much now, and the labor intensive activity of jute plantation does not allow, and availability of PP is also there. We have gone for PP bag. But the problem is that PP bag needs to be either recycled, or if it goes into landfill, then it harms the environment incalculably. The plastic is considered to be disposing into thousands of years, if not lesser. So we need to understand impact on environment, electricity, greenhouse gases, emissions of scope 1, 2, 3, and safety parameters that are going to impact on social implication. Continuous improvement, we have already discussed in the previous slide. Now we look at how the stages of the life cycle perspective work out. In the planning stage, we can draw up a process map from start to finish, how the processes are going to lay out, conception to ultimate disposal or recycling, identify key stages, stakeholders, and environmental impacts of each step. This is going to be a big paper exercise. As I told you, you can do it on primary level, secondary level, and tertiary level. Well planned is half done. Then on designing stage, we can understand what kind of materials are used, what manufacturing processes we need to deploy. So if you are going for tooled up process of press parts, or you are going for laser cut process parts, in the laser cutting, the time required is very less, but the efficiency or the quality of product comes out better in tooled up parts. So if there is a better combination, when we have large volume, go for dies and punches. If we have small volumes, go for laser. That decision also needs to be developed out. Then what kind of energy consumptions are there on each stage? And energy need not be only electricity. You can think of coal as well as LPG or any other fuel. Transportation requirement, from mine itself you need to understand, to steel plant, from steel plant to child part manufacturer, from child part manufacturer to your equipment plant, from equipment plant, finished product needs to be transported to markets, depots and dealers, from dealer to customer, and customer then uses in the field. All those transportation must be understood, and the cost should be factored out, and diesel and exhaust gases coming out during transportation can also be worked out. Finally, the end of life disposal option, what kind of scrap would be generated, can be thought of at design stage. So what kind of material you are going to use in design? On the weight front, what you can work out. On the efficiency front, what you can work out. On plastic front, you go for weight reduction, but if it can be converted to metal of a lesser thickness and still lesser price, then we can obviate the use of plastic, which has been taking over our industry in a big way. So lot of possibilities are there when we are designing our product. Then in production, we involve life cycle perspective, monitor and manage the manufacturing process to ensure using renewable energy, implement waste reduction strategies, and optimizing transportation logistics within plant and between plants also. The goal is to minimize the environmental impact at every step of the production cycle. At distribution, transportation methods, packaging methods, logistics required need to be reviewed. From emission and waste generation, the use stage focuses on the active lifespan, evaluating the energy consumption, maintenance requirement, potential for reuse or recycling. So if we are lengthening our product life cycle, that is going to help environment in a big way, support market such that our product gains brand image, even if we are going to be affected by lesser sale. If we get a better market and better image, probably customer is going to understand that and go in a bigger, give us a bigger market share, compensating for the loss that we might have incurred in lengthening our product life. Finally, at the end of life, what can be disposed at a economical level to scrap, which can be remelted, what may not be collected, and therefore it goes into sporadic landfill in various cities or hinterland, in the field, in the well, in the water stream, in the air. As much as possible, if it can be collected and disposed in an environmental friendly way, that is going to help the Mother Earth, and that will help us in putting our annual report also in order. Because now this is becoming a requirement in our BRSR related report or EcoVadis report or many other such initiatives. What is the importance of life cycle perspective? It enhances environmental and sustainability performance. It considers upstream and downstream impacts, holistic understanding of environmental footprint, and empower organization to drive sustainability. So all these activities that we are doing are going to help on sustainability, upstream, downstream impact, holistic understanding, footprinting, and empowering ourselves as well as our associated organizations. Once we are doing this activity seriously, we are helping our associated organization to also work out on life cycle perspective and improve their economical and environmental balance sheet, which they also might be grappling with in the new world order and new regulatory norms that the companies are facing. So what are the LCP methodology? It involves comprehensive evaluation, products and services or processes across its lifespan. Methodology identification, you can go for simple aspect impact analysis that we do in our ISO 14001, have additional column for energy, waste generation, and type of waste, type of energy. If you have 3-4 columns and start with that, you have a life cycle related study for each of the stage at your ISO 14000 aspect impact analysis step itself in a very nice way. Then you extend it to your plant upstream, your plant downstream, and at consumer level, and you have a beautiful life cycle perspective worked out. So this is one of the methods that we can think of. There are certain case studies in the market, in the Google, if you do it, case study of a brewery plant in Mexico, wherein they try to understand what kind of water or what kind of glass or what kind of energy is required in various plants, and they've tried to compare. And in the comparison, then you would understand how the profitability comes out if you understand the life cycle perspective in a better way. If we look at diagram on the right side, we have life cycle assessment, life cycle costing on the top. This depends on life cycle phases of material production, mold manufacturing, use of mold, end of life, which are going to give you cost evaluation, inventory, and environmental evaluation. Assessment include data collection. We need to consider both direct impact and indirect impact, such as environmental footprint of upstream supplier, carbon emission associated with transportation and distribution. This data collection must be analyzed and interpreted to give us an understanding how it can be interpreted. You assess. For that, you develop tools and framework. Tools and frameworks are available, or else we can develop our own tool from the ISO aspect impact analysis itself, you can add columns and work on it. You can quantify and compare impact categories such as greenhouse gas emission, water usage, and resource depletion. From wood point of view, steel point of view, rubber, plastic, and various other elements. Initially, you can go for 70% or 80% of the total component of the product. So you can leave initially 20% lesser significant products that go into your full vehicle manufacturing. Later on, you can add. So slowly and slowly, you can build on your inventory of life cycle perspective. As we say in auditing, we have 5 methods of data collection and analysis. These 5 methods are surveys. So you go for various companies and look at what kind of energy consumptions are there, what kind of diesel consumption are there, what kind of manpower is involved, what kind of electricity is there. So survey will give you some result, or you can go to various websites which publishes such kind of benchmark data, and that can also help you compile those things. You can take interviews of plant heads who have these figures on their fingertips and understand what kind of energy and emissions these companies are having. You can observe going to the process and understand what kind of emissions are there, and going to the motor number plate, you can understand what kind of horsepower that motor has. And on the electricity front, then you can look at electricity bill and understand what kind of wattage the company is consuming. You can discuss with focus groups of electrical engineers in any cement plant, power plant, or each of the plant which have lot of data with them on energy consumption. With mechanical maintenance team to understand what kind of scrappage they are generating due to maintenance. With the design team, what kind of improvement they have done on the product front. With production team, what kind of improvement they have done in Kaizen in the process front, and how many vehicles they have turned out or equipment turned out, and what needs to be done. So these are the when finally you can look at document and record. These are the 5 methods of data collection. Once the data is gathered, that needs to be analyzed, and you have to identify a pattern between various kind of data so that you can develop your own conclusion. It requires a detailed analysis. You have to identify trends of market growth, timing of product introduction, withdrawals, evolving customer preferences, shift in competitive landscape. So this enables anticipation and adaptation of changes in the market more efficiently. So if you understand that cement, 20% of the project sale now is started into, let us say, jumbo bag, and if your company has yet not started jumbo bag, you need to understand how this is going to help you on cost saving, on bulk transportation, on getting your jumbo bag for refill back to the plant, and how the company needs to be investing into developing the packaging system for that. It may require several lakhs of investment, but you need to work out how the return on investment can be obtained. So after working out and identifying trends, you need to uncover the insight. The insight can be from drivers of customer demand. So if people were going with low, smaller contractor, now multi-stories are being developed by large contractors and organized companies in real estate. Similarly, if vehicle market is totally regulated, then you need to go only to large companies. This is going to help you understand the data is going to be at organized level available. Only thing is to go to the right area to ask for it. Impact of technology advancement, as I told you, jumbo bag is slowly taking over. What kind of technology advancement is needed for the same? Similarly, if EV is going to come into the market, electrical vehicle is going to come into the market? Is it going to also go into mining? Is it going to go into your construction industry? And if it goes, how the landscape is going to change? What kind of parts are going to change? Where it has started all over the world? And you can be improving your business also accordingly. Influence of regulatory changes and role of organization capabilities in shaping the life cycle trajectory. If there are regulatory changes, if government is asking, or if some discussion on in COP is having, the discussion is on some kind of emission reduction, and if you are not prepared for it, tomorrow if the regulation becomes strict, you are going to be out of business, or that process of yours is not going to be workable. So it's better to be monitoring what kind of regulation are going to be hitting the market and be ready to adapt it. For example, BRSR report or sustainability report or recovered has hit on the market for last 3-4 years. Those who have understood, developed mechanism, developed data gathering capability, worked out the report, they are on the front runner. If any customer asks for the recovered score, they are ready with the answer. With that, they are able to offer more product or better product in the market. So having environment on your side with life cycle perspective is going to give you edge in the competitive business also. These insights can help to develop more effective strategies and decision-making processes. It's a holistic approach. Consideration of interconnected nature of the various stages and factors enable organization to gain a more nuanced understanding of the complex dynamics at play and make more informed decisions aligning with long-term trajectory of the product or service. How do you apply this insight? You identify hotspots, pinpoint stages with higher impact, where you have more fuel impact or fuel consumption, more electricity consumption, more emissions to the environment, and these become your first priority to attack. You optimize those processes and innovate solution. Once you do this for highest priority point, then go for secondary and third level of impact. Such kind of insight will help you on systematic improvement of your processes, improve your competitiveness, give motivation to your team to work on, and develop better stance on life cycle assessment. This is going to reduce waste, find ways to improve efficiency, optimize your existing processes, and enhance overall sustainability. You need to redesign manufacturing steps, rethink supply chain logistics, implement new recycling and end-of-life strategies. True power of the life cycle perspective is to inspire innovative solution. Interconnected nature of each stage help develop novel approach that tackle challenges holistically. Like investing in renewable energy, developing closed loop material flows, or completely reimagining business model to align with circular economy principles. This is a very big call, not easily taken. Therefore, CEO or top man of the organization must be constantly thinking of it, motivating teams to work on it, ask for presentation, ask for data, work on improvement, work on solution, and then they are going to gain out of it. By deeply embedding the life cycle perspective into strategic decision making, drive transformative change and position organization as a leader in sustainable future ready solution. Not a big call, it can be done. The insights uncovered will be invaluable in guiding path forward, helping create lasting value for stakeholders and the planet. So such kind of case studies are available on beverages packaging. different packaging alternatives, aluminum can, glass bottle and PET bottle, the function of which was protection of food products holding beverages, a functional unit of 1,000 liters of beverages, for example, 1,000 liters of juice that can be carried by glass bottle, aluminum can and PET bottle. And boundary condition is cradle to grave. When this analysis was done, some output was there, and these outputs are discussed in the given case study. This is available on Elsevier, which is a journal of cleaner production, on 10th September 2016. So life cycle perspective as a word was introduced in ISO 14001 2015. Lot of additional standards are there onto it. If you go for some kind of serious working, you have various more standards. What are conclusions and recommendations? Go for holistic approach, go for data-driven insight, have a collaborative approach with your child part supplier, with your upstream supplier, manufacturers or suppliers or principal, whatever you call them. Have your dealers also into confidence, and then try to educate your consumers, including drivers, mechanics, and fitters, whoever are going to handle the product during maintenance in the use case. Finally, you will have to go for continuous improvement, because that is the only activity that you continuously do to remain competitive. With life cycle perspective understanding, you have more areas to work on besides engineering related innovation to environmental related innovation on reduction of energy, electricity consumption, reduction of metal content, reduction of plastic content, so that your products are still available for the better use in the market, with better scrap related activity in mind, with better reuse in mind, so that world comes out to be a better place and company comes out to be a better competitive industry. So I was to complete at 12:15. We will look at some standards which are there in life cycle assessment. So we had 14041 in 1998, gold in scope, definition and inventory analysis. We have ISO 14042, which is for life cycle impact assessment. We have 14043, 2000, which is life cycle interpretation. We have 14040 of 1997, which got improved to 2006 version, and 14044 again in 2006 for requirement and guideline. The 14044 2006 of requirement and guideline is the standard which can be referred for life cycle assessment in much detail if somebody is going for serious working. There is a note that ISO 14040 2006 and ISO 14044 2006 replaces previous standard. So these are going to be little. Let us look at this diagram and keep it for question answers to come. We have product life cycle model to understand. We have cradle to grave analysis, then cradle to gate analysis, then cradle to cradle analysis. Such kind of small analysis we are going to do. We are going to help environment in a big way. So thank you, participants. Hope you have found the discussion in the new as a new knowledge. If you have already not gone into it, if you have something to contribute, I welcome you to write on a chat box so that I also understand it. Yes, madam.
Thank you very much, sir, for such an informative talk. It was indeed a great knowledge sharing that you have given us, and the most important and recent topic that is of importance to understand about sustainability and how we can contribute to sustainability to product and process life cycle assessment. May I request the participants to please participate and ask the questions either in the chat box or directly by unmuting them. Am I audible? The participants, the platform is now open for you to ask questions. Hello,
Yeah, can I have a question, please?
Yogesh sir,
Yes,
am
please.
I audible to you?
Am I audible?
Yes, sir.
Thank you, Yogesh Sahab. Really, I do
Am I
appreciate
audible to you, Yogesh
you.
sir?
Are you
Hello?
getting me? Yeah. Is it okay?
Yes, I am getting you, sir.
Yeah, yeah. So it was very nice, excellent presentation, and you could cover all the aspect of life cycle. Only I do a lot of review for the audit done by other people. When I ask this question from them, that is a requirement of ISO, especially when they do the environment management system. The mic, they reply back that they are not the consumer, they are not the user, so it doesn't apply to them. So there is a lot of confusion, and in fact, with your presentation, they should know now the requirement exists for everybody. Can you put little light on this one, please?
Yogesh sir, you've got muted, sir.
We as auditors have big responsibility. This presentation is developed when a team was asked the question what you are doing on life cycle perspective for a large construction equipment manufacturing company in the audit of 14,001, and they were just not able to answer. They were clueless. And they asked me, can you give us a training on life cycle perspective? Now, there is a single word of life cycle perspective in ISO 14001 2015. I tried to understand what kind of literature is possible to get. There is a person who is doing PhD in life cycle assessment from NITI Bombay, which has become IIM now, who happens to be my engineering college junior. I got a presentation from him, understood their processes, the text behind it. Then I understood the processes, what are involved at that construction engineering industry, which is making construction vehicle. Then I also, from my experience of steel plant, added my understanding from mine to steel plant to HR coil manufacturing and how it can be applied. With that, I could understand. Initially, I was also of the view that it's a very small thing. Aspect and impact analysis, add your emission and electricity, probably life cycle would be worked out. But when I went into upstream and then into downstream, and then understood cement related issues with my experience at Birla Corporation, I could have a holistic view myself. I would say that this topic stayed on my mind for something like 5 to 6 months because they got late in getting the training done. And we started developing the program, improve, then further improve, then further improve. And therefore, it became something like 6 to 8 hours training program for which I had to prepare a lot. So, if such kind of preparation is also going in the minds of uh, stakeholders and they do a paper analysis and they ask other people who are involved, they are going to justify it in a better way and bring benefit to the company also.
Excuse me, sir. I'm Sridhar from Lamtoff Limited, Hyderabad. There are some products which cannot be recycled. How can we explain in the life cycle perspective aspect? as per ISO 14001 environmental management system. The products which cannot be recycled.
Very good. There are certain products which cannot be recycled. But for example, we have pencil cell that are manufactured by companies like Panasonic or Duratuf, whichever company that must be manufacturing. These go into domestic uses, and these domestic usage are, once they are used, either they are thrown on the road or they go into garbage bins. Small pencil cell cannot be sold to a recycler officially or this thing. But if you recall that there was a issue of Nokia battery, and Nokia people replaced the battery by taking back. So if some kind of drive is there, like I'm from Indore, where we have got cleanest city award for last 7 years now, and every garbage vehicle has a small box for hazardous waste behind it. And if that battery can be, if through advertisement, through public awareness campaign, if we tell the masses and population that such kind of product has to be going into hazardous waste box. And if you do that, that will be better for the environment. It cannot be recycled, but at least it won't go into your general landfill, but it will go into systematic area where something usable can be brought back to recycling. For example, the shell, which is metallic, can be recycled. The inner content, which are not possible to recycle, can be chemically neutralized and then may go into landfill. So a small amount will be usable, small amount will go as a waste.
Thank you very much. What is the, then we have to bring in our MSDS. My MSDS.
Yogesh sir, amazing presentation, a lot of insight. Thank you so much for your time, sir. Sir, I see there are a lot of concepts that float around, sir. So my understanding is a little different. Industries feel that if you implement certain things which will have infrastructure modification, that is something which the industry accepts with a pinch of salt. Uh, is the role of a good consultant who can, devise good mechanisms out of his experience crucial in implementing it well? Because what happens is, as assessors, they have very limited freedom to suggest, whereas consultants, when they spend time and can design systems and unique approaches because they're implementing for various companies, is that the key to a start point? Because you remember the days of the 9000 when they started, we would have a lot of consultants who did good systems, and then other companies kind of, took on that system, and it became a very mature system as of today. But these systems are like ESG and the farm to fork concept and life cycle. These need certain infrastructure. So can a consultant's role be amplified, wherein he can, actually give sustainable and cost-effective solutions to good implementations? Over to you, sir.
You are very right, but the issue is consultant also need to be armed. There are not many training programs happening. People are learning BRSR or EcoVadis or such kind of ESG requirements through 4 days or 5 days of training. There are not much literature. Pressure is there on companies to implement without acquiring right kind of knowledge. If the knowledge is being imparted, large companies, 2 or 3 persons go for training, and then they are just calculating on their front, but not involving major stakeholders or all HODs within their plant. Key is where a consultant is able to first arm himself with the knowledge, then deliver that knowledge to a group of HOD at least, or deputy HODs if more possible, and then work on solution. Because penalties in the case of BRSR EcoVadis are very high. If you go for CBAM understanding, you are not going to be able to export to Europe from 2026 April itself. And if the steel is not green and if the carbon content is not up to the mark, the levy is up to 25% of the cost. So it is in the interest of the business to work on the processes and improve the environmental component. Even if they spend 10, 15, 20% of the total outlay, for years to come, it is going to benefit them. So regulatory hit, a customer hit, stock exchange hit, financial banks hit, and government pressure. All these are now coming onto the industry. Industry is better prepared, I must say. Consultants have to really gear themselves up and offer solutions to the industry.
Thank you, sir.
Any more questions? Deepthi madam, please go ahead.
Any more questions? If there are no more questions, we take the privilege to thank to our speaker for the excellent presentation as well as the topic that he has shared with us. Thank you very much, sir, once again. With this, we would say that we come to an end to one more knowledgeable session of Sadhguru Sangh. And to more details about Sadhguru Sangh, ICS is also pleased to provide you all with its research and development. That is integrated management systems like QMS, VMS, POSHAs, excellence in education management, ISO made in Gujarati, other languages like Marathi, Telugu, and Hindi. For reading any of the above group, you can contact the person and the details below. We would like to have your feedback in the feedback form, which you can find after registering on www.sadgunsang.org. And please provide your feedback. That will help us give better and better sessions more. Thank you for being the part. Thank you for being the part of Sadhguru Sangh on the today's session of Lifecycle Perspectives. Please feel free to contact us at the given address below. Now we proceed for the thanking ceremony. Thank you very much.